Okay, I now have 5 different displacements and the times to go with them for the metal ball and the plastic ball. Okay, first thing I'm going to do is try and calculate the velocity of each of these trials to see if I'm getting roughly the same velocity for each case. And if the metal ball and the plastic ball are moving relatively constantly, I should get about the same value every time. Okay. Now I could do this by hand, but Google Sheets, as we've seen before, can calculate stuff for us, and I'm going to show you how to set that up in your Google Sheet. First thing you need to do is hit the equal sign in a cell. That tells Google Sheets, I want to calculate something, and now it's ready to do so. So whatever I type in here now, when I hit enter, it's going to basically act like a calculator. So if I take like 3 plus 6, it's going to give me a value of 9. And if I hit enter or move to a different cell, it doesn't say 3 plus 6 in the box. It says the answer, which is 9. Or if I say equals, and I say 15, and I want to say minus 5, I do a little dash there, it should give me a value of 10. If you need to multiply something, we use the asterisk key. So if I'd say like 3, and I want to say times 5, I use a little asterisk here. Asterisk 5. That's 3 times 5. That should give me 15. If I need to divide something, I use a little slash, like the one in the centimeters per second label up there. So if I take, say, 20, equals 20 slash 4, and I hit enter, it calculates it for me. So I could take equals my displacement, negative 5.0, slash 0.10, and that will give me the velocity in centimeters per second. And that works. And you can go and do that for every single box, but that also takes a while. So here's a shortcut. If I say equals, and I click on the box I want to use for something, like this negative 5.0, it's going to reference that based on where the box is. It's in column C, row 6, so it's called C6. And right now it has the value of negative 5.0. If I want it to be divided by this time, I say slash, I click on that time, and again, it references B6. So now I'm in column B, still in the 6th row. If I hit enter now, it's going to take C6 divided by B6, which in this case is negative 5.0 divided by 0.10. I hit enter, and I still get the same answer. Okay, I'm going to hit X on this for now, just so I don't ruin the surprise. Okay, the great thing about this is if I go and change these later, like, ooh, that was actually supposed to be 1.0 seconds, it will automatically recalculate the velocity for me. So if I reference by where the box is and not what's currently in it, if I change the boxes later, it'll automatically recalculate the velocity for me. I don't have to redo all my calculations. Now you can also copy this equation so that it acts the same in the next row and the next and the next, where it takes the displacement divided by the time, displacement divided by the time. Okay, whenever you're interacting with a box, there's a couple things you can do with it. If I want to highlight multiple boxes or multiple cells, I'm clicking somewhere in the middle and dragging to select whatever I want, like what we do to make a chart out of distances and times. Okay, if I want to be able to move a box, I can click on the edge where I get this little hand, and it will scooch it over to wherever I drag it to. Let me undo that. If I want to copy a cell, then I want this little blue circle down here at the bottom, where if I click and drag that, okay, it'll copy that value over. So if I click and drag on the corner of this negative 10 cell all the way down, it'll replace all of these with negative 10. If I do this for an equation, it copies the equation. But it knows that I want to take this divided by this, and this divided by this, and this divided by this as I go down. So if I click on this cell here, it now says equals C7 divided by B7. This divided by this. This guy says C8 divided by B8. So this is C8 divided by B8. So I can copy the equation, and I don't have to keep retyping it, and it will know I want to do this by divided by this, whatever numbers are actually in there. Makes it a lot faster. I'm going to do the same thing down here. Equals this divided by this. I hit enter. Sometimes it'll suggest to fill in an equation that's kind of noticed a pattern here. Just make sure that it does calculate it correctly. Sometimes it'll give you a formula that has a dollar sign in it, which usually dollar signs are good. But in this case, it's not what we want. That means it's fixing a value instead of moving on to the next row. So if you're using C6 or B6 or something like that, and then you try and copy the equation, it'll still try and use one of those while using the one on the next row, which is not what we want. You can always check the equation to make sure that it is what you want, and this looks pretty good to me, so I'm going to hit the check mark. And if it gives you the wrong equation when it tries to predict what you want, you can always hit the X and then retype it in. Okay, but this is just another thing that can make it a little bit faster for you. Okay, so for the metal ball, it could be better for sure. Like there's a lot of these here that are close to like negative 45 to negative 60 centimeters per second. But then I've also got this negative 83.3, which is kind of off quite a bit. There's a big difference there. The plastic ball is a little bit closer. I get somewhere between negative 16 and negative 21 or 22 with these. So they're pretty consistent. But still, I run into the same problem I had with the tumble buggy, which is I need to be able to make sure that I eliminate the errors of me trying to time it out physically by averaging between them. And better than I can do just by adding and dividing by however many trials I did. So now that I've seen that it looks like this should be a pretty consistent speed, it's just my data is not good enough to show it consistently, I need to make a graph that does give me one velocity for how fast the metal ball is moving. I'm going to click and drag where it says time taken over to displacement, include all these numbers here. I, again, don't need the velocity because we're going to get the velocity by using these displacements and times. So I click and drag, highlight all my times and displacements. I include the titles to help Google Sheets figure out what I want. I go up to Insert. I say Chart. And hey, that's already a good start. I've got a chart that has dots on it. I've got displacement here. I've got time taken here. It's looking good. If I go to Customize, I can change the series of this, the Y value, the displacement, to show its trend with the time going the other direction. If I scroll on past the fun stuff like changing colors, I can go to the trend line option down here, check that box, and it will shoot a line through these points to try and average out between the areas where I'm a little bit too far to the left or too far to the right on some of these data points. If I go down a little bit farther, I can hit Use Equation, where this number in front of the X is the slope. And that slope should be the speed, or in this case, the velocity, in centimeters per second, where the negative means this is going at 56.9 centimeters per second downwards versus upwards. Okay, I can do the same thing for the plastic ball and go make its graph. Select, insert, chart. It guessed that I want a scatter chart. If not, I could always go and change the chart type to what I need. Scroll around until I find scatter. I customize the series. I scroll past the fun stuff to get to the trend line. And then I go a little bit farther to change the label to use equation. Okay, and I do get a number that is smaller than that negative 56 number. I got negative 21. Now, negative 21 is less negative, but we're looking at how steep the line is, and that's all about the value of the number, whether it's positive or negative. So negative 21.4 centimeters per second means that this is moving at a slower velocity downwards than the metal ball is moving at a slower velocity downwards. Okay. Now, I'm going to see if I can get these on screen at the same time. So let's see if I can scooch this. Try and make these the same width. Okay. And again, this is kind of a good example of how you have to be careful about comparing the steepness of these lines. Because these are on separate graphs and because the time scale is different, the slope looks pretty much the same. Looks like it's got kind of the same angle to it here and here. But if you look at the time axis, I'm covering this distance, this negative 75 centimeters here and here, okay, in a much longer time for the plastic ball than it is for the metal ball. And just so I don't get them mixed up, I'm going to change this title by clicking on it a couple times. I'm going to say velocity of metal ball, hit enter. On this a couple times, change this to velocity of plastic ball. Okay. So if you don't have lines on the same graph, just be careful if your axes aren't being compared in similar ways. Like if you don't have the same time axis along the bottom, like how this is going to 3 seconds and this one's going to about 1.3, 1.4 ish. Okay. In those cases, check out the slope. Negative 21 means that this is going 21.4 centimeters per second downwards, whereas this is going 56.9 centimeters per second downwards. So a greater displacement per second, the metal ball is moving faster.